This presentation is to introduce some of the new features of LUSAS version 16 and is intended for people already familiar with the general capabilities of LUSAS. We can describe version 16 in 3 words: simplify, collaborate, design. What do we mean by those words? Well, we're talking about making LUSAS easier to use and more productive. And we realise that this has to be both in terms of creating models and also in terms of obtaining the results you need quickly, efficiently, and in a repeatable way. And when it comes to collaboration, that might mean working in multidiscipline teams with federated BIM models. Or it might just mean working with other LUSAS users and merging models together. But it's, again, about speed and it's about productivity. And design. Everyone knows LUSAS for its analysis capabilities, but we're adding to that. One of the highlights in version 16 is the launch of a new Steelwork Design module, but that's just one of a range of new or improved design tools. So let's start by simplifying. When you start modelling, you know if you're going to create a grillage model, or a 2D frame model, or a 3D model, or maybe a axisymmetric model, a slice on a cylindrical object like this settlement tank. Well, now you tell LUSAS that. It's the analysis category. There are just those 4 options. When you've made that choice, what does it mean? It means the rest of your choices are much simpler. You only see the relevant elements. So it's a much shorter list. Here, it's just a grillage element or a joint. You only see the relevant support directions. The others are grayed out. You only see the relevant load directions, the right geometric properties, and so on. If you've ever had an error because you put a 2D beam into a 3D model, well, you won't ever make that mistake again. Once you're into building your model, you'll find things look a lot nicer, as the new perspective mode makes it easier for you and your clients to make that connection with the real structure and to navigate around it. While you're working, you'll find that various panels, like the tree view and the text output area, can now be unpinned so that they hide and reappear when your mouse moves to them. This gives you more screen space for the graphics area. You can now select multiple items in the various tabs of the tree view and make changes such as changing the load factor or deleting items in one operation. You can also now create your own layout grid where you specify X and Y spacing. It's just an alternative to the infinite regular grid in previous versions. You can have multiple grids as seen here to help you create your model quickly. And of course, the grids are for rapidly creating points, lines and surfaces. Just click and drag to create multiple lines. You might have noticed that the grid labels there are shown in the plane of the grid, and indeed all labels can now be rotated to axes local to the lines or flat to the screen. That's any label for line and surface numbering perhaps, or for diagrams and so on. Some new functions have been added to the section property calculators. There's this compound section property calculator, defined using existing library sections or user sections, positioned relative to each other, and allowing mixed material properties in one section, but assigned to lines and fleshed in the same way as any other geometric attribute. There's also infilled sections, a whole range of boxes and pipes with and without stiffeners, and encased boxes, pipes, and eye girders in circular or rectangular encasement. There's always the arbitrary section property calculator for any shape you like, but for thin sections, we've removed the need for you to manually draw lots of narrow surfaces. Just draw lines and assign suitable widths. As we think about getting results in a rapid and repeatable way, let's start with beam, shell, slice resultants. These are hugely improved. Firstly, you can define and store as many slice paths as you like. Here there are 2, and you can see the 2 bending moment diagrams right there on the model. So we have a mixed shell and beam model, but the stresses are being integrated to obtain results of the same type you'd get from a beam or grillage type model, with the same convenience using the diagrams layer or the print results wizard or any of the usual functions. Results update as you set the locators active, and it's fast, a lot faster than before. Lastly, it works with combinations, enveloping, and all reporting tools. It may not sound much, but it's actually a game changer. The greatest advantage of grillage models over more advanced approaches was the rapid extraction of results. Now that's no longer the sticking point. Similarly, when surfaces are sliced to obtain a graph from a contoured result, these can now be displayed directly on the model as a diagram, as well as in a dedicated graph panel. A new corridor averaging option enables you to obtain results averaged over a specified width to help with the interpretation of elastic stress concentrations. Inspection locations allow us to define where exactly the results we're interested in lie. Those results might not coincide with the node location, but that's okay. LUSAS will interpolate. So we can examine results at, say, quarter points across this slab deck. And when we change the mesh, the results are still given at the locations of interest, no matter where the node and element boundaries are. Like slice resultants and graphing, inspection locations can be used with all the usual post-processing functions. They can be defined with actual or parametric distances within a line or a surface, or just freehand with the mouse. Contour results are typically smoothed by nodal averaging. In this extreme example, one surface in the slab has been reversed. The peak moment at the pier might have been, say, 300, but averaging plus 300 and minus 300 would zero that peak, so you could miss the maximum value if you didn't notice the problem. But that won't happen in LUSAS version 16. The new intelligent averaging is the default, and it doesn't average between neighbouring features if the angle between features exceeds a tolerance or the normals are opposing, or if the neighbours have different attributes, or if the lower order features have assignments where you have supports assigned to a line on the edge of a surface, for example, or at a junction of 3 or more features. Similar rules apply for results on beams, in volumes, and so on. All this makes LUSAS easier to use and helps us to eliminate errors. Now, to collaborate, we need to share the information about our model and share the results in reports. In many projects, we may be asked to meet BIM level 2. Or several engineers might work on parts of the structure and then bring them together in a merge. The print results wizard is widely used because it's so easy to export and share results in Excel. We've improved the interface, and now your inputs are saved in the Utilities tab of the tree view. This means that you can regenerate your Excel format results at any time, when the model has been changed, for example, at just a double click. And you can see here the windows are neatly tabbed for you. The report writer already compiles graphical results plots, graphs, results tables, and even just model data automatically and in a repeatable way. Whenever you click, it generates live and up to date. Now you can generate those tables of data more conveniently by referencing in your print results wizard tables. The tabular format has been improved to be much clearer, and the report writer runs more quickly, defaulting to the PDF format, the standard used for documents in BIM. And you can also add notes to the model and reference them in your reports too. Speaking of BIM, LUSAS now helps you reach level 2 compliance by allowing you to store model data in IFC format. The IFC files from different disciplines are brought together for the federated model, which can be used for clash detection and later passed to the client along with other project data for maintenance purposes. LUSAS writes IFC4 files, and you can export to either the structural or architectural domains. The structural domain is intended for analysis programs like LUSAS, but many BIM viewers don't support that domain yet, and so we have enabled an export to the architectural domain as an alternative. You can export just the features, points, lines, surfaces and volumes, or you can include the attributes too. BIM standard attributes are in IFC format, while LUSAS specific information such as analysis properties or slide lines are kept as private data. LUSAS can also import IFC files and of course will recognise its own private data on import. Here's a model stored as IFC as seen in a free BIM viewer. But of course these functions are not just for buildings, despite the acronym BIM, they are for all construction, for any LUSAS model. We also know of teams where engineers don't just share data, they divide structures up to complete designs in a shorter time frame. That's where the new model merge comes in. With one model open, you can merge in another, as many models as you like. The function will even rationalize identical attributes, avoiding duplication. And now for design. Adding to our existing Eurocode Composite Deck Designer and RC Slab Designer is an all-new Steelwork Design function. Choose one of the available design codes. Define and assign the additional design data required. Yield strength, buckling strength, that sort of thing. The results of the Steelwork Designer checks can be viewed just like any other result in LUSAS. This contour plot shows some members utilised 114%, overutilised, and others as little as 12%. So we could optimise those members. The checks for the code of practice selected are right here as a new results entity. But if you want to see all the details, all the clauses, go here to the design menu. A summary of checks is shown to the left and all the details on the right. Every clause number and formulae with all the values substituted so you can follow every line of the calculations, and you can print them or add them to a report. To help you in any design work, we've added a new design combinations function, automatically generating factored combinations to a selected code of practice. You just have to identify your load cases using the categories from the code. A whole range of codes are supported. The RC Slab Designer has also been improved. It already covered a large range of design codes, but crucially now designs using both bending and in-plane effects. A major limitation removed. In line with the Steelwork Designer, you can now define RC slab attributes and assign them to different parts of the model and obtain results in all the usual ways: contours, graphing, print results wizard, and so on. The Traffic Load Optimizer now covers even more international codes of practice. These are the additional codes. There are many others already available for countries all over the world. If you work in seismic zones, our new response spectrum library will probably be a big help. And for any dynamic analysis where you'd like some applied loading to be treated as mass, this little tick box will save you a lot of time. The multi-tendon pre-stress wizard has had a major engine overhaul. Instead of approximate losses requiring input of estimated concrete stresses, it now determines pre-stress losses based on time inputs and calculated stresses. That means it gives losses changing with time at each stage of construction, for example. And to help manage the stages of construction and the time associated with each, there's a new time management dialog, which includes a Gantt chart viewer. Changing the length of a stage automatically updates all subsequent stages, so it's a lot faster in use. And that's not everything. There are improvements in stage construction, buckling options, temperature-dependent materials, cable tuning, and more besides. Thank you for watching this presentation. We hope you'll enjoy using LUSAS version 16 to simplify, collaborate, and design.